In video 1, we created a CGA rule to generate 3D building models from 2D building footprints. In this video, we will continue building our 3D city model by creating a parcel rule. The parcel rule visualizes the landing use or zoning of properties. The city's zoning codes determine a parcel's setbacks and maximum heights, which in turn determines possible building forms. We will show this as a 3D volume that represents the largest building that can be legally built upon the parcel. The zoning is also displayed thematically by colors chosen by the city. So the first thing we should know is what type of GIS data we have for the parcels. So let's start by importing the parcels from the parcel geodatabase in the CityEngine Essential Skills Training project. First, let's go ahead and turn off the building layer. In the navigator window, expand the CityEngine Essential Skills folder and the data folder, and drag and drop the parcel geodatabase into the viewport. Click Import and wait for the parcels to be added to the scene. Next, align the parcels to the terrain by right-clicking on the parcels layer in the scene window and choosing to align shapes to terrain. Make sure the height map is set to terrain DTM and choose one of the align functions. I'm going to use translate to maximum and then click finish. Zoom in a little to better see the parcels. Click on one of the parcels and show the object attributes in the inspector window. The parcel shape has many attributes, but we will use the attribute called category. If your parcel has no value for category, then switch to one with a value. Mine says commercial. Let's start by creating a new parcel rule. In the Rules folder, right-click and choose New CGA Rule File. Name it GIS parcel.cga. Our first goal is to apply color to the parcel based on category, so let's make an attribute in the rule for this. Before we start writing the rule, from the window menu, I'm going to change my layout to Rule Editing Standard so I can better see the CGA code. Now leave a space under the version number and type ATTR parcel color equals quote quote, which is an empty string. Add this annotation above the attribute which tells the inspector to display a color. At color, and then make a start rule. Leave a space under the attribute and type at start rule, and under start rule type parcel and the rule notation -- greater than. Then use the color operation as the first step. So type color, open parentheses, and use the name of your attribute, parcel color. Then close the parentheses. In video 1, you might remember the color operation as having 3 parameters, R, G, and B. Open the help file and search for the color command. Just type in color in the search box and choose the first option, color operation. The second option here is the one that we used in the last video. The first color operation takes a single parameter, a string sometimes called a hex color, since the RGB colors are represented in hexadecimal format. Now to see the hex color, select a parcel and apply your new rule. The default value is blank, so you see no color on your parcel, but in the inspector you have a color picker. Click on the black bar to launch it. Use it to pick any color you want, then hit OK and the parcel changes to that color. You can now see the hex color as the attribute value. So you've applied a single hex color to this parcel manually. Now, how do we apply colors based on our object attribute category? To access the object attribute from CGA, we make an attribute in our rule with the exact name of the object attribute. Make the default value be an empty string. Type ATTR, then category, in uppercase letters, equals, and 2 quotation marks. Save the rule and generate. Usually when a rule attribute matches an object attribute, the rule attribute will automatically link to the object attribute. If not, then select the parcel and open the connection editor. Then choose the third option, Object Attribute. Now your category attribute should display the object attribute. Our next step is to color the parcels using the official colors used by the city. Here's an example of a zoning map used by the City of Redlands. We want to try and match the colors that the city uses for zoning. We will assume that the city has furnished this color data. In CGA Video 1, we learned how to use the case structure to control conditional logic inside a rule. We will use cases again now, but this time we have already coded this and included the code in another CGA rule. CGA rules can import other CGA rules and call any of the rules and functions inside that rule. This is a powerful tool featured in most languages. For example, this allows multiple CGA rules to reference commonly used functions or rules without maintaining duplicate versions of the same code. To see this in action, look in the navigator and find the reference city zoning CGA rule. Now drag and drop that rule into your parcel rule. Commonly, imports are placed at the top of the rule, but this is up to the author. You now see the following code in your rule: import, reference city zoning, rules, reference city zoning.cga. The word after import is called an ID, and it's used to make reference to the imported rule. Following the ID is the path to the imported rule. The ID can be any name, so let's shorten it to make coding quicker. Just change reference _ city zoning to ref. Before we can use any imported CGA rule, we must know what's inside it. To view the rule, double-click the reference city zoning CGA rule and it will open in the CGA editor window. You will see a function containing the zoning colors. In general, a function is an equation or a series of conditional cases which returns a value. This function is parameterized so that it can receive input that influences its output. Read the description in the comments at the top of the rule. The input to this function is a string, seen in the parentheses after the function name. The parameter is named category, and that parameter is only accessible inside of this function. We are using a parameterized function so that the other rules may use it with the most minimal of setup. Next, observe the case statement. Each line can be read like this. In the case that the parameter called category is equal to the value administrative, then return this color hex code. There is a case for each possible value of our category object attribute. And all case structures need an else case which can be used for errors or missing data. Here we're using the black color to indicate the error state. One thing to note about functions is that they don't handle geometry, they only handle numbers, strings, and Boolean values, which only have two values, true or false. Another important note about the use of cases is that every case must be handled and no code can lie outside of the cases. So if I type this just outside of the first case, print, and in parentheses category, notice that we get an error here. So let's go ahead and remove that line. Now let's use this function to color our parcel. First, copy the function name and parameter. This doesn't just save time, but it also reduces coding errors. Then switch back to the parcel rule. We are currently picking the color through the inspector. In the first line of the parcel rule, select the parcel color attribute and replace it by pasting in the function from the imported rule. You will now see an error, and if you hover over the error, you will see no function category. We want to replace the lowercase parameter name with our uppercase category attribute. There is still an error, but if you hover again, you see that it says no such function, get color per category. Remember that when we imported the reference rule, we gave it an ID of ref. Since the function is inside the imported rule, we need to label it with an ID ref. In front of the function, type ref followed by a full stop. The error should go away now. Just to keep things clean, let's disable the earlier coloring code. Put comments in front of that code as follows: hashtag in front of @color and a hashtag in front of @parcelcolor. This turns the code into comments so that they won't run. This is very useful when writing code, and it is called commenting out the code. Now save and generate. You should see your parcel colored by the city zoning colors. Zoom out to see all of the parcels. Select all of the shapes on the parcel layer and assign the rule, and then generate. You will see the map reflect the zoning categories for every parcel. Remember that the black parcels are the ones that have missing or incorrect data. At this point, we can demonstrate how our imported reference rule can be reused by other rules. So let's color the buildings using the same technique. First, copy the import statement and paste it into the building rule underneath version. Then copy the attribute category and paste it in with the other attributes in the building rule. I'm going to paste it under the roof type attribute, just after the else statement. And lastly, copy the color operation and make this the first line of the start rule building footprint. Use Ctrl F to find any remaining coloring code and remove it. You can see that the wall rule still has the color green. So let's put a final shape with the terminator behind the wall rule as follows. Type final wall with a full stop and then save the rule. In the scene window, show the buildings layer. Right-click on the buildings layer and select all objects in the same layer, and then click Generate. You can see that all of the buildings are black. Remember that the color black is from the else case that catches errors. Look at the category attribute in the inspector. It has no data. In our parcel rule, the category attribute was mapped to the object attribute of the parcel shape. We need our building rule to map to the same object attribute on the parcel shapes. With all of the building shapes still selected, open the connection editor on the category attribute. Click the final option called Layer Attribute. Select the parcels, then select the source category object attribute. Once you click OK, you will see the buildings regenerating with the same colors as the underlying parcels. Sometimes this is not an exact science, as the buildings may cross parcel borders or the parcels may lack data. The specific way that this layer attribute mapping works is that an imaginary vertical line is located at the centroid of the building shape. The parcel shape that hits this vertical line will be the shape sampled by the building. This color coding we have applied is used by cities to communicate the land uses and building forms allowed by law. Our final task is to model the maximum buildable form, sometimes referred to as the zoning envelope. Turn off the buildings layer now. Reducing the number of models displayed makes CityEngine faster and more responsive. First, we'll create a buildable footprint by applying setbacks. You can think of the setbacks as a minimum yard size. To simplify this effort, we'll only apply setbacks to the residential parcels. To determine what is residential, we'll make a Boolean function which returns true or false. Type this function: is residential equals and on a new line, case category which is the same name as our attribute, a double equal sign, which tests for equality, then type single family residential in quotes, and let's add an OR, which is a double pipe symbol. On the next line, add our attribute category again, two equal signs, and then multifamily residential in quotation marks, and notice there's a hyphen between multi and family. Then add a colon and type true. True is a Boolean value. So what we've said so far is if category is equal to single family residential or multifamily residential, return the value true. Else, return the value false. So add the else case, add a colon, and type false. So this function tests if something is residential by looking for those two values. Sometimes with Boolean functions, it's easier to write a shorter version. Just set the function equal to the case being evaluated, like this. Copy and paste is residential equals open parentheses. Copy and paste the condition being evaluated into the parentheses and then close the parentheses. And we can put all of this on one line. This works because the condition being evaluated returns a true or false. So we've just set the function equal to that value. You will see an error because you cannot have two functions with the same name. This also applies to rules, constants, and attributes. So just delete the first function. Now save the rule. One more addition to the function. Change it to a constant function by adding const in front of the function. During generation, this function will always give the same answer, so the answer is constant and unchanging for any particular shape. To stop CGA from running that function more than once, we specify it as a constant. Then every time we ask for this is residential value, it's already been calculated. Also note that attributes behave the same way. Every change in the inspector triggers a regeneration with a constant attribute value. At the end of the parcel start rule, send the original parcel shape to a new rule called make setbacks. Then start the rule somewhere below. Type make setbacks, 2 dashes and a greater than sign. And let's put a comment to note what's happening here. Hashtag only making setbacks on residential parcels. Then add a case structure. On another line, type case is residential. A colon. And on another line, make front yard. And then add an else case. Make envelope. The case structure will send the shape to the setback rules only if the constant function is residential is true. The next rule is the one we call if the parcel is residential. We can copy and paste the make front yard rule name for convenience sake. Type 2 dashes and a greater than sign to make it a rule. And on another line, type the setback operation. So type setback, open parentheses, and then a value in meters. We'll say 5 meters for the front setback and then close the parentheses and open the curly brackets. And like the comp function from video 1, we'll use selectors to send new shapes to new rules. The first selector is street.front. Type a colon and call a new rule named yard. Place a pipe character and use a second selector called remainder. Then type a colon and send the remainder to a new rule called make backyard. And then close the curly brackets. This says to make a 5-meter setback shape and send it to a yard rule, and then it sends the remaining shape to our next rule, make backyard. Now you can copy and paste the make front yard rule for convenience and then modify it as follows. Change the rule name to make backyard. Change the setback amount to 7. In place of the street.front selector, change it to street.back. Still send that to yard. And then the remainder will be sent to make side yards, plural. And once again, to make the make side yards rule, copy and paste the make backyards rule and modify it as follows. Change the setback to 2 and change street.back to street.side, and let's send the remainder to make envelope. Change the rule name to make side yards. Notice that we call the make envelope rule from the else case of the make setbacks rule and from the remainder of the make side yards rule. Only residences use the 3 setback rules, while other shapes bypass that sequence and send the entire parcel shape into the make envelope rule. Start the make envelope rule and add the 2 dashes and the greater than sign to make it a rule. Then press F1 and find the CGA operation called envelope. Page down to the diagram to see what the envelope operation can do. The angles used are sky planes or view planes, used by some cities to control access to sunlight. Our city doesn't use this type of zoning, so let's keep this simple and use the extrude operation. Type, extrude, open parentheses, max height, and close the parentheses. This line will produce an error. If you hover over it, you can see it says no such function max height. So we must make a function that returns the max height. Also, we will reuse the isResidential function. Type const, C-O-N-S-T, then type max height or copy and paste from the extrude function, equals case, then type isResidential, which you could also copy and paste from your isResidential function. Then type colon and the value you want to use for the max height when the parcel is a residential parcel. I'll use 12. Then type an else case, else colon, and we can use 24 for the max height of non-residential parcels. This shows how you can put the entire case structure on one line. Now save the rule, select some parcels and generate. Now zoom into your selection manually, or you can press the F key on the keyboard or the frame selection button at the top of the viewport. As you apply the rule to more shapes, check the orientation of the yards. The front and back yards should be larger than the side yards. You should see that some are wrong. Here are some in my scene. To correct this, select the edge along the street. You'll have to double-click the edge. Right-click the selected edge and choose Set First Edge. You'll see it regenerate with the correct street orientation. To apply this correction to all of the parcels, CityEngine has a built-in function. First, turn on the streets layer indicated by the street network icon in the scene window. And to save processing time, right-click the parcels layer and choose Delete Models. Then right-click on the parcels layer and select all objects in the same layer. Then run Shapes, Compute First Street Edges from the menu bar. This will take a moment to run. Note when CityEngine creates parcel shapes from a street network, this happens automatically, but when the streets are from GIS data, the street edge will need to be computed this way. Once the process has run, generate the models again to see the difference. You can see what a difference this makes when we look at the models that were generated before we computed the first street edge. Now let's go back to the rule. We will need to see the buildings inside the envelopes, so add this line of code at the end of the make envelope rule. Type set, open parentheses, material.opacity, 0.4, and then close the parentheses. The set operation sets the value of certain material attributes, in this case the opacity. Now the envelope is transparent. Also note that the transparency only applies to the current shape, which is the extrusion from the previous operation. In fact, all material settings, colors, and textures are only applied to the current shape and shapes derived afterwards. No settings can carry backwards through the rule. As a final step in the parcel rule, let's make a switch to turn on and off the envelopes. Make a new attribute. At the top of the rule, type attr show envelope equals true. Then in the make envelope rule, change it to this. Add a case structure at the beginning, so type case show envelope colon and leave the next two lines as they are. Then type else colon buildable footprint and add a full stop. Then save the rule. Now we're done coding CGA for this tutorial. Zoom out and generate the rule on all parcel shapes. This will take a moment. When it's finished generating, turn on the buildings layer with all the models generated. Then double-click the top of the viewport to maximize it. The visualizations of buildings within parcel envelopes is a practical example of zoning compliance. We are, of course, using very simplified data and rules, but the concept is the same. The buildings should be inside the envelopes, and this is a quick way to visually check whether the buildings comply. In the next video, we'll use procedural modeling for urban design.